Hello students, welcome back to the lecture class 3 on refrigeration and air conditioning of chapter 2 module 3 elements of mechanical engineering course. So today I am going to discuss about the refrigerant properties, types of refrigerants. What is a refrigerant? Refrigerant is a chemical substance. It is a fluid. Fluid means it is a liquid or a gas. It is called fluid that absorbs heat from a substance or a given space by evaporating at low temperature and pressure. The refrigerant does not undergo any chemical change, but phase change takes place. That is, liquid to vapor, vapor to liquid, phase change takes place. But it does not undergo any chemical changes during the refrigeration process. So it is a chemical substance. Without the refrigerant, you cannot use the refrigeration process or air conditioning process. So as I told you, it is like a blood in the human body. How the blood is how the blood plays very vital role in the human body. The same way, the refrigerant plays a very important role in the refrigeration process. So refrigerant is a chemical substance. It absorbs the heat from the refrigerated space and it evaporates to the atmosphere. Next example. What are the examples of refrigerants? Ammonia, sulfur dioxide, carbon dioxide, methyl chloride, freon, etc. These are some of the examples of refrigerants. So they may ask you a question, what is a refrigerant? Give example. You can write this. It is a chemical substance that absorbs the heat from a substance, a given space, refrigerated space, by evaporating at low temperature and pressure. The refrigerant does not undergo any chemical changes, but phase change takes place from liquid to vapor and vapor to liquid during the refrigeration process. Examples are ammonia, sulfur dioxide, carbon dioxide, methyl chloride, freon, etc. Next, what are the properties of refrigerants? Very important. The 6 marks question. What is a refrigerant? Discuss the various properties of refrigerants. We have different property. First, thermodynamic property. It should have low boiling point. So boiling point should be low. Low freezing point. Freezing point should be low. High latent heat of vaporization. High critical temperature. So these are all thermodynamic properties. Physical properties. Low viscosity. Next, low liquid specific volume. High thermal conductivity. High electrical insulation. Next, chemical properties. It should be non-toxic. It should not be poisonous. It is non-flammable, non-explosive. Non-flammable. It should not catch a fire immediately. It should not catch a fire. Non-flammable. Non-explosive also. It should not be explosive material. Non-corrosive in nature. Okay. It should not have corrosion properties. Should not corrode. When you use, it should not corrode. Good chemical stability should be there. It should not change immediately. It should be miscible with lubricating oil. Miscible means it has to mix with the lubricating oil, because we have to mix with the lubricant. Refrigerant should be mixed with the lubricating oil. It should have that kind of property. It should be miscible with the lubricating oil. Next, other properties are availability. It should be cheaply available. Okay, it should have low cost, easy of handling. It should not hurt our fingers, hands, human body should not hurt. Okay, should be easy of handling and no impact on ozone layer. It's very important. It should not have any impact on the ozone layer. So these are the 4 important properties of a refrigerant. Next, types of refrigerants. So there are 2 types are there. One is primary refrigerant, second secondary refrigerant. What are primary refrigerants? Primary refrigerants are those refrigerants directly they take part in the refrigeration system. Okay, directly they take part. They are called as primary refrigerants. Okay, examples: ammonia, sulfur dioxide, carbon dioxide, freon, modern refrigerants, high HFC, hydrofluorocarbon. So these are all comes under the category of primary refrigerants. So they directly take part in the refrigeration system. Secondary refrigerants means these will not directly take part. First, they has to be cooled by the primary refrigerants, and then you have to use for the cooling purpose. Example: calcium chloride, sodium chloride, glycols. We'll discuss about these primary refrigerants in detail. So ammonia, the properties. We should understand about the property of each and every refrigerant. Ammonia is the oldest refrigerant, but widely used and cheaply available also. Colorless gas, boiling point is minus 33 degrees Celsius. It is soluble in water. It produces high refrigeration effect. RE means refrigeration effect. It produces high refrigeration effect, not harms ozone layer. Okay, not harms. Next, it is toxic in nature, that you know very well. It is not miscible with the lubricating oil. It will not mix easily. So explosive, moderately is explosive one, is moderately flammable. Okay, it will catch a fire. Irritating and corrosive in nature. Not suitable for domestic refrigerator because it is toxic. We should not use in our refrigerators. It is used for only large commercial applications like ice manufacturing plants, packaging plants, cold storage. So where the gas, the poisonous gas, is not at all a matter for the making ice. Okay, the big plants, ice making plants requires they have to cool. Some, say for example, they have to big ice cubes they will make. They only for cold. Okay, make it a cool. That using ice cubes we can just cool the place. That is, we are not consuming that. We are preserving a fish, as we are preserving some kind of cool drink bottles. We are preserving some sort of any vegetables. Okay, it's for cold storage. We are making ice. It's used for large commercial applications like ice manufacturing plant, but it's not should not be used for our refrigerators. Ammonia should not be used for refrigerators. Next, sulfur dioxide. It is non-flammable, non-corrosive, dissolves in oil. Boiling point is minus 10 degrees Celsius and has low refrigeration effect. It absorbs lot of heat in evaporation. Lot of heat. It will absorb lot of heat. Okay, that is small one within a cycle, within a 5 cycles it will absorb the heat. At the same time, ammonia takes 10 cycles to make it a cool. But if 5 cycles, just I am telling an example, within 5 cycles of operation, you will get the cool space. But in the case of ammonia or other things, it will take a lot of time to make it a cool. So it absorbs a lot of heat in evaporation for every cycle. It irritating odor and suffocates. Sulfur, you know that it irritates and it suffocates also. In presence of moisture, it forms a sulfuric acid that is a corrosive to refrigerator parts. So olden days refrigerators used but now it is not. It is obsolete. Obsolete means it is out of fashion, is outdated one. So that is obsolete. So this is about the sulfur dioxide properties. Means carbon dioxide is non-toxic, non-inflammable, inexpensive and odorless gas. Boiling point is minus 77.6 degrees Celsius. It is nearly 1.53 times heavier than air. So no need high operating pressure which lowers it needs high operating pressure which lowers the efficiency. Okay, operating pressure increases means efficiency will decrease. The low specific volume makes the small unit compact. So you can make it a small unit so that you can use it for large ships, cinema theaters, etc. You can use it for the carbon dioxide as a refrigerant. Next, Freon. So it is very important. Freon group of refrigerants are highly efficient and overcomes all the disadvantages what we have seen from ammonia, carbon dioxide, sulfur dioxide, but is harmful to the ozone. It's very important thing. It's harmful to ozone. So again, that is why the researchers are finding a new one. What best we can use the refrigerant. They are keep on. Now the work is going on. They have a very good and efficient, which is not having any harmful for the ozone or any greenhouse effect. The research work is going on. There are two types of Freon refrigerants are there. Freon family, there are two types. Freon 12 is R12, Freon 22 R22. R means refrigerant. Is a commercial name is R. R stands for refrigerant. 12 is Freon 12. Okay, Freon 22 is refrigerant 22. About this we are going to discuss now. Freon 12 and Freon 22. So Freon 12 is a chemical formula is CCl2F2. That is dichloromethane. Is non-flammable, non-explosive, non-corrosive, odorless. Boiling point is minus 29.8 degrees Celsius. Is used in small capacity refrigerators. We can use domestic refrigerators also. This Freon, water coolers, air conditioners, automobiles, etc. So Freon 12 can be used. Next, Freon 22. A chemical formula is CHClF2. CHClF2, chlorodichloromethane. Similar properties of Freon 12. So how the Freon 12, what are the properties are there? Same properties Freon 22 is also having. The boiling point is minus 40.8 degrees Celsius. High pressure refrigerant, used in large capacity plants. Next comes modern refrigerants, hydrofluorocarbon HFC. See this Freon 12, Freon 22, they have a chlorine content. Because of chlorine content, there is a depletion of ozone. Okay, chances of ozone depletion. So that is why modern refrigerants they have come into use. They are hydrofluorocarbon HFCs. So here the fluorine atoms are there, which is not harmful for a ozone layer, but is harmful for a greenhouse effect. Okay, so carbon dioxide is there, so greenhouse effect problem is there. So it is a family of hydrocarbons containing one or more several fluorine atoms, but no chlorine atoms. So no ozone depletion. So good thermodynamic properties are there for health and safety also. It is alternate for R12 and R22. So R12 and R22 now we are not using because it damages the ozone layer. That is why we are not using. We are using hydrofluorocarbons. R134 is one of the best example for use refrigerators. The tetrafluoromethane CH2 FCF3 is a hydrofluorocarbon with no chlorine atom. It is non-corrosive, non-toxic, non-flammable. Boiling point is minus 15 degrees Celsius. It is identified as a replacement of R12. So we instead of R12 we can use R134. Refrigerant 134 is a tetrafluoromethane. Next, R134 is used for medium temperature applications such as air conditioning and commercial refrigeration, and widely used in modern car air conditioners. Other hydrofluorocarbons are like R407C, R410A, etc. You can use it as a alternate for the Freon 12 and Freon 22. The hydrofluorocarbon has no effect on ozone, but it has an effect on global warming to some extent. Okay, global warming is greenhouse effect. So again, that is why the researchers are working on this refrigerant. What best we can give the refrigerant for a air refrigeration process. Thank you for watching this video. So there will be a 6 marks question. What is a refrigerant? What are the different properties of refrigerant? Explain in detail. And what are the different types of refrigerant? Discuss the different refrigerants. Like that also 6 marks question will be there. So this video will give you totally 12 marks. Okay. So thank you for watching the video. Again, next class we are going to see the next topic. Thank you.